In this video we will talk about base width modulation, also known as Early effect. Early is the name of the scientist, and on the name of him it was named Early effect. So what is this called? This is also called a base width modulation. From the name it seems that the base width will be increasing in the process. So how this happens, let's see. This is a transistor, an NPN transistor, as most of the transistors are NPN, they read it as NPN. Okay, and so this is the base, this is the emitter, and the base is, from the positive of the battery it is connected, so it's forward biased, and this is the reverse biased. This is the collector is connected from the positive terminal, so it is reverse biased. So overall this transistor is working in active region. Okay, so we will see what's the early effect in this, or what the base width modulation. Since this junction 1, let's call this junction 1, there is a junction over here, P and N type. So this junction 1, this base width will be, the junction's width will be same until and unless this potential is applied. If this potential is applied, then this will further decrease. Okay, this potential is making this junction forward bias, so this depletion width will be decreasing. Okay, so this depletion width will be decreasing. This is base, and this reverse bias causes this depletion width to increase. When the diode is connected in reverse bias, the depletion region increases. Okay, so here it is a reverse bias connection, and you can notice that when this reverse bias is connected, then this junction width will be increasing. Okay, this junction width will be increasing. And how the things will be, let's see. Let me remove this first, it will make you think easy. What will happen when this reverse bias is connected? You know that the base is lightly doped. Okay, so when the two parts, this P type and this N type, is connected and reverse bias is applied, then we know that the minority charge carriers start flowing from one to another, and this depletion region will develop. And we know that ρ1 x1 is equal to ρ2 x2. Means if this is positive charge, then if it is taking this much distance, this is small distance in this collector part, then this will cover a large distance in this base region. This is what ρ1 x1 is equal to ρ2 x2, and this is why this is so. This is to maintain the electrical neutrality. Okay, because here the charges, the same amount of charges will be available in this much distance only, but here to cover those amount of charges, you have to go, this electrons will need to go for a longer distance to maintain the neutrality to reach to the holes. So in the base region there is a larger penetration. Okay, so larger penetration will be there in the base region. This is called base width modulation. Now this effective base width will be increasing. You can see this part will be the part of depletion layer, no charges inside. Okay, so this is called base width modulation. So what's the result of this? What's happened? What is the effect of this process? So as you can see, now let me remove this once again. What happens after doing this? As you can see that if the P type, if the this first junction, when this will be forward biased, then the holes from this, this is P type, then the holes will go from this to this, but these holes have been finished. How these holes have been finished? because of this reverse biasing. This reverse biasing have led to the decreased amount of the holes. How? This is so because the electrons in this n type will they have matched up with this this holes, okay, and so the amount of holes have decreased over here. So amount of holes have decreased over here. Do you get it? Why the holes have been decreased? Because of this reverse bias. Okay, the electrons have matched to those holes and their numbers have been decreased. So what has happened due to this? Now due to this, the emitter current will decrease. The emitter current will decrease because what is the emitter current due to? Emitter current is due to the mixing of holes to this electrons. Okay, the holes will go from here to here, but the number of holes have been reduced now. Okay, so what's the impact due to this? Let's see. We know that I have been decreased. Emitter current have been decreased. And what will be when I will decrease? Then you know that alpha is IC by IE. So when IE will decrease, then absolutely alpha will increase. Okay, so alpha increases and in this process. Okay, IC will be much more remain the same. However, IC also depends on IE, but I is decreased, then alpha will increase. So you have to remember this process, early effect and what is its effect on current gain, this alpha. Okay, so hope you got the topic. Thank you for watching.